Take a look at this example. It's a Python script that takes an input image and then applies a couple of filters on it. Now, as you can see, there are some imports here with different types of filters. And then there's a process image function that then uses these filters and then creates an actual image out of that. Now, this looks pretty innocent, right? But if you take a look at the process image function itself, you see that again, we have these filter imports. And then we have the actual process image function, which then checks what kind of filter it's dealing with. And depending on the filter, it's going to apply different settings to the filter. Now, you might be able to improve this design a bit by maybe, I don't know, moving all this code to the main module. But then your main module becomes larger. You may try to improve the design of these various filters to make them more the same. But the problem remains that this function and the main module as well, they both depend on specific filter imports. And if you add more filters to the system, that basically means you're just going to get more and more and more imports. It's fragile and it's hard to test. And if you need to add new filters, you need to edit these files over and over again. And this is how you get spaghetti code. So in this video, I'll show you how to fix all of this with abstractions. Python doesn't force you to use them, but once your project grows beyond a few basic modules, abstraction can actually be really helpful to reduce imports and therefore coupling, and also make your code a lot easier to test. Now, I'm going to use image filters in this video as an example, but this is about making any Python code easier to work with, extend, and understand. If you want a deeper guide on software design and learn the 7 steps to come up with a great software design, get my free design guide at ArjanCodes/design guide. The link is also in this video's description. Now, abstraction, why is that so important? Well, in a sense, what you're trying to do is you want to shift your code from describing what it does to kind of how it does it. So instead of specifying concrete implementations, you try to bring that all together under one thing. And that basically describes the process of how those specific implementations typically do things. Now, when you rely on concrete implementations everywhere, just like I showed you in the example before, that means you create a lot of tight coupling. Your code becomes harder to reuse. You may end up with circular imports. Basically, it quickly degrades the quality of your code. Now, Python lets you avoid this by using various types of abstractions. So then the question is, how can you set this up differently? Now, before I show you a few different ways to do this, let's first take a look at the original code. So I've already shown you the main file and the process image file. So that's what these look like. But we also have a folder with filters. This is at the moment pretty basic. We have a grayscale filter class and we have an invert filter class. And this is what these files look like. So you can see these are basically classes with some properties and attributes. Like in the case of the grayscale filter, we have an intensity, we have a name, and then we have an apply method that basically applies this filter with a particular intensity. And then we have a configuration method, so that you can actually set the intensity of the filter with a dictionary of values. And the idea is here that you can basically configure this with different types of dictionaries, and in the future we can add different types of attributes so that we can change various properties of this filter. And in case of the invert filter, there is no special behavior here. It simply has a name and it inverts the image, and that's it. And I'm using the pillow package to do all this work. I didn't code this up from scratch, obviously. Now let's take a look. When we run this code, I'm using UV, by the way, to manage this project. But basically what I have here, I have an input image, which is this very handsome guy. And we're going to apply these filters by doing a UV run main.py. And now it has done this. And now we get the inverted, and we also have a grayscale image. So that's what this code is doing. Now, the first thing you might want to consider is using abstract base classes. This is kind of the classic way in Python to do abstraction. So what happens in that case is that you take these filter classes and you try to abstract away from them. So we have the classes at the moment, they're very specific, right? We have grayscale and we have invert. But what you would do with an abstract base class is that you provide a sort of contract for these things. So what I've done is I've created another version of this example that uses abstract base classes instead of this just randomly defined classes. And that's in this folder. So in principle, my main file still looks roughly the same. We still create these specific filters and we import them from these modules. But if you now look at the filters folder, you see that there's a new file called base. And this is the base of what a filter is supposed to look like. It's a contract. And that is exactly what abstract base classes do. So in this case, you see there's a property, which is called name. So each filter needs to have a name. We also have an apply method. So it basically applies the filter to an image. And we have a configure method that sets configuration parameters for this particular filter. That's what this looks like. This is the contract. And now what you can do is modify these specific filter classes so that they follow this specific contract. So grayscale filter is now subclass of filter base. It has an intensity, which is an internal thing. That's why I added a underscore here. We have a name just like before. And then we have an apply method that applies that filter with a particular intensity. And we have the configure method. So this is not very different from what we had here because basically the interface stays roughly the same, except in this case, we made it a subclass of filter base. We now have a contract that we have to follow. Now the invert filter looks a bit different. This is of course also a subclass of filter base. It implements this contract. And in this case, I just added a simple setting. You don't even need to do that. But now, instead of in the previous version where we had a do invert, which is of course different from apply, in this case, I changed it so that it follows the contract more strictly. So it also has an apply method now, and it has an enabled option. This, by the way, might be something you could even move into the abstract base class so that any filter can be disabled and enabled. Anyway, and I've added a configure method to this. So now the invert filter also follows exactly the contract. What's interesting though is if you look at the first version of the process image module, so that's this one, here basically my filter object had a type any because it could be basically anything. And then I check with is instance call whether we're dealing with grayscale filter or with an invert filter. Now, this is not a good example of great code, right? Often if I see is instance calls, it's kind of an alarm bell and I try to figure out why they're there and if there is a way to avoid using them altogether and maybe replacing it with some abstraction, as I'll show you in a minute. But of course, in this case, you could fix this kind of without abstraction by basically making the filters more the same, but then why not just use an abstraction and make it official? So if you do that, if you do make it official, then this is what it looks like. So as you can see, this is way shorter. What I've done now is I've imported the filter base. There's no more is instance checks. I don't need to do that. And I supply a filter object here. And then instead of using any, I can now actually specify the type. And then I apply the filter. Simple as that. Now I made another little improvement here, which is that the process image function in this first example actually directly sets configuration things. Now that doesn't make a lot of sense. And that's more of a design issue of where you should do certain things. So instead, what I'm doing in this version of process image is that I don't apply any settings. I simply apply the filter and save the image. That's the responsibility of this function. But then in the main file, you see that that is actually where we set the intensity. Now by doing this, by introducing this abstraction, it has a couple of nice effects. So one thing is that it kind of forces you to make sure that there is one place where you're basically putting all of this together, and that is in the main function. So that's where we have the specific imports. That's where we're saying, hey, we want a specific grayscale filter, or we want an invert filter that is enabled. And then the other methods, other functions, other modules, they don't know that much because they're relying on abstractions. So process image, for example, it has no idea what kind of filter it applies. It just knows I just get an object that has this contract of filter base so that I can call methods on it, or that I can print the name of this thing because that's specified in a contract. And that is exactly what abstraction achieves. And as you can see now, also in terms of imports, I don't have to import specific filters here anymore. Of course, I still need to do that in the main function, right? here I still import them because, well, that's where I'm patching up everything. And that's typically something you want to strive for, that in your code base you're going to end up with basically one place where you're putting together everything. That's like the dirty spot in your code, right? Every clean room may be perfectly clean, but there's also always a little corner that is a bit dirty. And we need that. We need that dirty corner. And that's also the case in code. We have one place where we patch everything up. And often that's going to be the main file. That also gives you a kind of measure of how successfully you've decoupled your code and applied abstraction. Is there a single place in your code that is messy and the rest is clean? If that's the case, then you're probably doing a pretty good job. Now, this is abstract base classes. And one of the things that you see with abstract base classes is that we need to have this inheritance relationship, right? That's how it works. That's how Python verifies that you actually implement the contract. For example, if I remove this subclass, so now it's just a class, but if you then look at the main file, you see that we now get an error here that invert is not assignable to filter base. It's not a subclass of filter base, even though it implements the methods and the properties. With ABCs, you need that explicit relationship, that inheritance relationship. That also has advantages. For example, it means that you could store some attributes in the base class, and then that attribute is accessible in all the subclasses. That can be helpful, for example, in the case of this enabled attribute. You know, if you want to have that for all filters, then you would move this to the abstract base class. But you might say, well, it's maybe not so Pythonic to do it this way. I mean, Python has duck typing that works different than this system of sort of static type checking almost. So as an alternative, what you can do is use protocols, which is more closely aligned to how Python's typing system works. And I know there's people who don't like them. There's people who don't like abstract base class. I'm kind of in the middle. I use both, but I typically tend to use protocols more than abstract base classes. So how are they different from the abstract base class example that I've showed you just before? Well, if we take a look at this folder, which has a protocol version of this, if you take a look at the filters folder inside that, you see we're back to two files. There is no base class here. And if you take a look at the actual class definitions of invert filter and grayscale, you see that there's no inheritance relationship. Now that saves you an import, which might be nice, but at the same time, it's basically up to you at this point to make sure that when you're writing this code, that you're actually following the contract of how filters should work. On the other hand, and this is a key difference, in the process image module, you now see that we have a protocol class that specifies, hey, what does a filter base look like? And this is then what we pass as an argument, same as what we had with the abstract base class, except that we're defining the protocol here because we're purely using it to specify the contract of this particular argument of the process image function. But there's no inheritance relationship. And that means that I can create filters using different classes with different methods. However, of course, when I go to my main file and I try to use them, well, then at that stage, we're going to get a problem, right? So in this case, for example, let's say I go back to my invert filter class and I'm going to rename this to apply invert. I don't get any problem here because, well, this is just a class. It's completely independent. But in the main file, we now see that there's an issue that, oh, actually, this is incompatible with the filter base protocol because the apply method isn't there. So that's when the check takes place. So that's quite different from how ABCs work. Final thing I want to show you is that I've now shown you how to use abstractions with classes, but it might make sense to use functions instead. In this case, a filter is basically nothing more than a function, right? So here's another version of that same example, but now I'm using purely functions. And you might think, oh, that's actually much better. There's definitely some advantages to using functions, but there's also some limitations, as you'll see in a minute. So with these filters, I've added a third one, because why not? Now, actually, the definitions are even simpler. I have my grayscale function. That's simply a function called apply grayscale. It gets an image, it gets specific configurations for particular filter and returns an image. And same for invert. So this basically only gets an image and then I'm applying that filter. And that's all there's to it. And then I have another example here which applies a sepia filter. It doesn't really matter what it do. But as you can see, the nice thing about using functions here is that these are actually really simple. But how do you then proceed to use them? Well, in my process image functions, also function, what you can then do is kind of abstract away by using the callable type. So that's what I'm basically doing here. So here I'm saying, hey, my image filter function is a function that takes an image and that returns an image. That's basically all that it does. And then process image, well, it gets this image filter function and it applies that function to the image and then saves it. And that's all it does. And probably this needs to be image.image. Yeah, that's probably better, because if I go to the definition here, there is no definition. Okay, type hints in Python, they're not perfect yet. Anyway, this is how I've set it up. It's quite similar to the protocol version in the sense that we define the type of the thing that we need here locally. It specifies the interface of process image. So that's interesting. These are both quite close to how Python's typing system works. However, of course, now we have a problem because grayscale is actually not a valid image filter function because it gets an intensity. That's where the magic of functional programming comes in. I'm back in the main file, and what I've done here is I've imported these filters. So I have my grayscale filter, which takes an intensity, so it's not a valid image filter function. But now I created another function called makeGrayscaleFilter, and this returns an image filter function. And how does it do that? Well, it uses a closure. So it defines another function that is actually a valid image filter function because it gets an image and returns an image. But then inside that function, we use the intensity that I'm passing as an argument here. And then I return that function as a result. So this gives me a grayscale filter function. So I can call this and then I have my function. And same for the invert filter. So I can have an enabled setting if I want to, and then I can define a filter function that is exactly an image filter function and then return that as a result. And then basically what you can do here is create your grayscale function by calling makeGrayscaleFilter with a particular intensity. And then I can call this function. And same thing for the invert filter. So now I'm using these functions. But, well, it's a bit cumbersome that we have to do this, right? It's a bit annoying. So another thing that you can do is use something called partial function application. And what this does is basically the same thing as makeGrayscaleFilter or makeInvertFilter, is that it defines a new function that it returns as a result. And it does that by already applying some of the arguments. So what you can do in this case is call partial, which is partial function application from the functools package. And then we supply it with the function, which is apply grayscale. So that's our function that gets an intensity. And then we can pass an intensity as an argument. And now what happens is that we don't need this makeGrayscale function anymore with the closure, because basically what partial does is exactly the same. It takes apply grayscale, it sets the intensity, and then it returns a new function where this intensity is already applied as an argument. And now we can use that to call process image. And I just realized that actually I copy pasted all this code here, but actually, of course, the way that you would do this is by calling a return apply grayscale with the image and the intensity. And for the invert filter, it would be exactly the same. So that's a bit more correct. So this is also pretty nice in terms of design. Now there are some limitations to partial function application. For example, if you go back to the process image function and you want to print the name of the function, so normally an object has a dunder name property that you can print, but actually partial doesn't return this. So you don't have access to that information. And that's just some of the limitations that you run into when doing something like partial function application. And by the way, if this video helped you clean up your Python thinking, hit the like button. It helps me a ton if you do that. And while you're here, why not subscribe to the channel so you won't miss any future videos. In short, it's really easy to end up with spaghetti code if you're importing modules all over the place. It starts small, but it becomes complex very quickly. So if you encounter this in your code, think about applying abstraction. If you need to abstract from functions, use Callable. If you need a structured class hierarchy with maybe a base class that has already some instance variables with values that are used and subclasses, use ABCs. Or if you need something that's closer to Python's typing system, use protocols. And if you're really into functional programming, use things like closures and partial function application. But be careful, because if the developers in your team don't have a lot of experience with functional programming, then it's maybe not the best solution either. But now I'd like to hear from you. Do you use abstraction? Which form do you prefer? Callables, protocols, ABCs? Let me know in the comments. Now, I used partial function application in the code example. If you want to learn more about that, what you can do with it, as well as some of the other features of the functools package that I imported that from, check out this video next. Thanks for watching and see you next time.